All right, welcome to section 1.5, a problem-solving plan using models. Our goal for today is to translate verbal phrases into algebraic expressions and use a verbal model to solve a real-life problem. Now, contrary to what we usually do, I'm actually going to go over these explorations because these are the key terms that I'm going to use throughout these notes. For addition, subtraction, multiplication, and division, we have different terms that we use to identify each of those terms. Or each of those operations. So for addition, some that you might hear for addition, we have add. We also have sum of. We have more than. We have plus. We have increased by. And I'm sure there's some other ones out there, but these are the ones that just come to mind really quick. Subtraction, I have difference. I have less than. I have minus. And I also have decreased by. For multiplication, not as many as these other ones, but I still can come up with product times multiply or multiplied, that works. And for division, I have divide or divided, and then I also have quotient. And there might be some other ones that might come up, but this is a good starting point for what we're doing today. All right, on to the notes. Writing algebraic expressions, equations, or inequalities that represent real-life solutions is called modeling. The expression, equation, or inequality is a mathematical model of the real-life situation. Now let's look at some examples. So write the verbal phrase as an algebraic expression. Use x for the variable in your expression. So number the first one, 4 more than half a number. Well, this sounds like it almost could be an inequality, but remember, our key word to tell us that it's not an inequality, but in fact, just using an equation, is that this is an expression. So we're not going to have any equations. We're not going to have any inequality signs. So this tells us, this expression, that there's not going to be an equal sign, and this helps us understand this a little bit better. So if I do this, 4 more than half of a number. Well, I know this right here represents a number that I'm looking for. I don't know what that number is. I'm going to say, hey, this is going to be a value of x. If I have half of this number, how can I say half of this number? Well, I can say 1/2 times x. If I do 4 more than half a number, I can say plus 4. Now, it doesn't matter where you have the 4. You could also have 4 plus 1/2 x. These are both acceptable answers. On the second one, 12 decreased by a number y. Well, let's start with the unknown value. We have the number y, so I'm going to start with that. And I have 12 decreased by a number y. So I know I'm taking 12 and I'm taking something away from it. So this will be 12 minus y. If I had it the other way, then I couldn't say that 12 is being decreased by y. It would be y is decreased by 12. So in this one, order does matter, and we only have one way of writing it. The quotient of 8 and a number. Quotient. Oh, we got one of those words here. So if we look at quotient, we know quotient from up here is division. So quotient of 8 and a number. So we have 8. Our first number is 8. So we're going to write that on the top. And the bottom number is going to go on the bottom. So a number. We don't know what that number is. It's going to be, we'll have to just give it a variable. I like to use x. And there you go. The fourth one, 8 less than half of a number. So start with the value that we don't know we have of a number. So of usually refers to multiplication. So half of a number means that we have 1/2 x. And if we have 8 less than this, what we are going to do is that we're going to be subtracting 8. This we cannot write in a different order. It has to be in this order. So it can't be 8 minus 1/2 x. It has to be 1/2 x minus 8. Go ahead and try uPractice, and then when you're done, go ahead and when you're done with all the uPractices on the sheet, check with Mr. Rakowski, and he'll tell you how you did. Example number 2. Write an equation to model the situation. Use mental math to solve the equation. Movie tickets cost $6 each. One day, the total receipts from ticket sales were $420. How many tickets were sold? Well, first off, we have to understand what are we looking for. So I know that I'm looking for how many tickets were sold. So I want to find out the tickets that were sold. And if we're going to write an equation, we want to have a variable that represents tickets that were sold. You could use X. Since I'm using tickets, I'm going to go with a T. So I'm going to say tickets that were sold equals T. Now, if I have movie tickets cost $6 each, what would happen if I had 2 movie tickets? So if I had 2 movie tickets, I know that would be there'd be $12. If I had 3 movie tickets, that would be 18. So all I'm doing is taking the number of movie tickets that I have and multiplying it by the price. So if I had 5 movie tickets, 5 times 6 is 30. So I'm going to say, since I don't know how many movie tickets were sold, that's what I'm looking for. I'm going to take 6 and I'm going to multiply by T. Now I know that when I do this, this will be equal to 420. Now we haven't learned about how to solve equations yet, but we can use mental math to solve it. So, or you can do trial and error. Trial and error is always good. So if you do it, we can say, all right, 6 goes into 420. Well, 6 goes into 42 7 times. So T equals 70. So the number of tickets that was sold is going to be 70. So we know 70. Now we don't want to just say 70. We want to tell what it is. We want to say 70 tickets. Go ahead and try the uPractice on your own. And then when you're done, we will check it and make sure you're good.